Hello, and welcome to our channel, a nexus for the inquisitive and perpetually curious. Today, we're looking at a really iconic image, aren't we? The flamingo, standing on one leg. It's just so elegant, graceful. But why do they do it? It seems simple, maybe, but it's actually been a bit of a biological puzzle.
Okay, let's unpack this. Our mission today is to sort of extract the key insights from our sources about flamingo adaptations. Basically, a shortcut to understanding this amazing behavior. This episode is adapted from an article by us, the Perpetually Curious, published on our Facebook page. It explores the ingenious adaptations of flamingos.
And ingenious is definitely the word. This isn't just some quirky pose they strike. It really reflects nature's brilliant engineering. These adaptive strategies, they've likely developed over very long evolutionary timescales.
Right. Millions of years, potentially.
Exactly. And while we might not know the exact origin moment, it's clear it's not just one thing. There are multiple factors contributing to why they stand like that. It's complex.
Okay, so where should we start? The most common explanation, perhaps. Heat. Yes. Thermoregulation, heat conservation. That's a major hypothesis.
You often see them, tucking one leg up, especially when it's cooler. And you have to imagine they spend so much time standing in water, often quite chilly water.
Precisely. Standing in shallow, sometimes cold, saline lakes or lagoons all day.
What would you even do if you were standing in cold water?
Well, you'd try to limit how much of you is in the cold, wouldn't you?
Exactly. Pull your foot out, maybe?
Sort of. By folding that leg up into their body feathers, they massively reduce the surface area exposed to the cold water or air. But it gets more sophisticated. They have this incredible countercurrent heat exchange system in their legs.
Okay, countercurrent heat exchange. How does that work? Simply.
Think of it like this. The arteries carrying warm blood down the leg run right next to the veins, bringing cooler blood back up from the foot. They're often intertwined. So the outgoing warm blood transfers heat directly to the returning cold blood.
Ah, so it warms the blood coming back before it chills the core?
Exactly. And it means the foot itself can stay cooler, losing less heat to the environment overall, while the body core stays warm. It's very efficient. So standing on one leg, it's probably just one visible part of this whole thermal regulation strategy. Not the only thing they do, but a key part.
That's fascinating, like internal biological leg warmers.
Yeah.
Very clever. It makes a lot of sense from an energy perspective, too, conserving that heat.
Absolutely.
But heat can't be the whole story, surely. You mentioned multiple factors. Let's move to the next idea, because this is where it gets really interesting, I think. Saving energy.
Yes, energy conservation through anatomy. This involves something called the gravitational stay apparatus.
The gravitational stay apparatus sounds impressive.
It really is. It's a feature of their anatomy, their bones and ligaments, that allows them to lock their leg joint in place. So they can stand on one leg with very little, almost no, continuous muscular effort.
So it's not like us trying to balance on one leg, constantly adjusting.
Not at all. It's more like a passive lock. A structural thing. This saves a significant amount of metabolic energy. They can just rest, locked in position. And get this, studies on flamingo cadavers, non-living birds, showed they could still be positioned stably on one leg.
Wow. So it's really built into the skeleton itself.
It strongly suggests that yes, that the stability is inherent in the structure, not just active muscle control. Evolution basically hardwired balance into their design.
That's incredible. It frees up their muscles and, their attention for other things, like watching for danger or finding food.
Precisely.
Okay, but we do see them switching legs, right? Standing on the left for a while, then the right. If it's so effortless and passive, why switch? Does the apparatus get tired?
That's a good question. The switching is observed. It's definitely a documented behavior. The logical inference is that it helps distribute the load, maybe gives one limb's tissues a rest, potentially reduces any minor fatigue or strain that might build up over time.
So like shifting your weight if you stand for a long time?
Kind of, yes. That idea makes sense. It's plausible. But proving it conclusively in studies, that's harder. It remains more of an inference based on observation, rather than something experimentally proven is the primary driver for switching. Measuring subtle fatigue or load distribution in wild birds it's tricky.
Right. The complexities of field research. Okay, so we have heat saving, energy saving through anatomy. What else is out there? I feel like I've heard something about parasites, avoiding things in the water.
Ah, yes, the parasite avoidance idea. It does pop up, especially in secondary literature. And biologically, it makes sense. Less food and water time could mean less exposure to waterborne parasites or pathogens.
Sounds reasonable.
It does. But the key thing here is There's currently no direct experimental evidence confirming this as a primary reason. It's a plausible hypothesis, ecologically sound, but we don't have studies that specifically show flamingos do it because of parasites. It remains speculative for now.
Okay, interesting idea, but needs more proof. What about just stability? Those legs look so thin. Does standing on one leg maybe help them stay upright on wobbly ground? Or if it's windy, seems counterintuitive.
You'd think so, wouldn't you? But laboratory studies looking at their biomechanics actually showed their legs provide remarkable passive stability even on one limb. Because of that stability shown in the lab, some scientists have hypothesized, yes, that it could aid balance on uneven surfaces or in windy conditions common in their habitats.
So the structure itself helps them stay stable, even on one leg.
The potential is there, based on the mechanics. But again, translating that lab finding to proof of why they do it in the wild, that link hasn't been rigorously tested with field studies. It's logical, consistent with the biomechanics, but we can't say for sure it's a driving reason for the behavior in nature versus maybe just a useful side effect.
This raises an important question, doesn't it? How do you test these subtle behavioral drivers in a complex natural environment?
Exactly. It's a constant challenge in biology.
Now, is this whole one-legged stance just a flamingo thing? Or do other birds do it too?
That's a great point for an evolutionary perspective. No, they're not entirely unique. Other wading birds, think herons, storks, they also often rest on one leg.
Oh, interesting.
Similar solutions evolving independently to similar environmental challenges, like keeping warm or saving energy while standing in water. And even birds that don't typically stand on one leg for long periods, like ducks or gulls, they also have that countercurrent heat exchange in their legs.
So the heat-saving mechanism is quite common, even if the one-legged pose isn't universal.
Correct. The fact that one-legged resting appears in multiple unrelated groups strongly suggests it offers real adaptive advantages. But the exact balance, how much is for warmth, how much for energy saving, how much for stability probably varies between species and even depends on the specific situation. It's still an active area of research.
If you enjoy thoughtful explorations like this, you can find more on the Perpetually Curious, available on blog, Facebook, and YouTube.
Okay, so it's a widespread, effective strategy. But thinking about these amazing specialized adaptations, does that make flamingos more vulnerable in some ways? Their whole lifestyle seems tied to very specific environments.
That's a really important question, and if we connect this to the bigger picture, several flamingo species face serious conservation threats, often driven by human activity.
Such as?
Well, the Andean flamingo, for instance, is listed as vulnerable. It's threatened by habitat loss from mining, which impacts their food and water quality, and also historical egg collection. Then you have the Chilean and James flamingos, both near threatened due to pollution, mining impacts, and climate change affecting their wetland habitats.
So their specific needs make them sensitive. Extremely sensitive. Even the lesser flamingo, which is the most numerous, is considered near threatened because the quality of the wetlands they rely on is declining rapidly in many areas. These birds are adapted for saline lakes, very particular ecosystems. Protecting those habitats isn't just about flamingos, it's about entire unique wetland ecosystems.
It really highlights how interconnected everything is. Their survival depends on these specific fragile places.
Absolutely. Protecting flamingos means protecting these vital, often overlooked habitats.
We cover science, nature, fauna, flora, history, arts, culture, and more. Follow the Perpetually Curious on Facebook, YouTube, and our blog. So, wrapping this up then, what does this all mean? What's the big takeaway?
I think the takeaway is that something seemingly simple, like a flamingo standing on one leg, is actually incredibly complex.
Right. It's not just one thing.
No. It's this amazing interplay of anatomy, physiology, passive stability, energy saving, all shaped by evolution. It's nature finding a really elegant multi-purpose solution, even if we're still figuring out the exact weighting of each factor.
It's definitely more than just a pretty pose. It's a masterpiece of adaptation. So next time you see a flamingo standing there on one leg, maybe pause and consider that intricate interplay of anatomy, thermoregulation, and evolution behind it. What looks simple is the product of these complex adaptations honed over vast stretches of time. And maybe think about other animal behaviors too. Which ones fascinate you? Which ones perhaps seem simple but might hide incredible ingenuity? It's worth celebrating all of nature's ingenious solutions. Thank you for watching. Visit the Perpetually Curious on our blog, Facebook, and YouTube for more related content. Share this journey with fellow explorers, and if you enjoyed the video, please support us by subscribing, sharing, liking, and turning on notifications. Until our next exploration. Bye for now.
Thank you for watching. We invite you to explore our channel, where you will find captivating content across a wide range of topics, from everyday wonders to engaging subjects like science, arts, nature, history, technology, and more. If you enjoyed this episode, we would sincerely appreciate your support. Please consider liking, sharing, subscribing, and turning on the bell for notifications. For those wishing to support us further, you may consider one of the following options. By tapping the Super Thanks button on YouTube, or through Buy Me a Coffee using the link in the description, or by scanning the QR code shown on screen. Your support is truly appreciated. Thank you. Before you go, take a moment to explore the related content here. You might just find your next favorite video. Thank you for watching.